Now, if we continue here, like we wrote n equals 0 here, 0 minus k will be the same, but just reflected with respect to the y-axis. Now, if I write h of 1 minus k, that means I'm going to move to the right. Okay, arkadaşlar? I'm going to keep the same signal, but this time 0 and 1. This is 1 minus k. Then I'm going to write h of 2 minus k. Okay, what is 2 minus k? This one. I'm going to shift this function 2 to the right. Okay, now it will be 1 and 2. The numbers are not changing here, 1 over 2. Okay, why am I doing this? I'm trying to help you to understand this formulation right now. What is being asked from me? Now x of k times h of n minus k, multiply these and add them up, and write everything into how much you have shifted to the right or to the left, and this will be the index of your output. Okay, so if we continue like that, this is my signal x of k. If I multiply this with h of k, what will be the output? There is no minus 1, so this is 0 times this, which is 0. And then I'm going to multiply 1 by 1 over 2 and obtain 1 over 2. And there are no other multiplications. You see, this times this, this times this, they are all 0. So I only have 1 times 1 over 2, which will be 1 over 2, which will be written as y of 0 as 1 times 1 over 2, which is equal to 1 over 2. Why? Y of 0? Because I did not do any shifting. N is 0 here. N minus k. N is 0, okay? I'm doing the summations using the k, using the summation variable. You see, the summation is over k here. So then what will I do? I will keep this as it is, arkadaşlar. I'm not doing anything. I am shifting this one, okay? Now, first, reflect, perform reflection, then shift by n, and then multiply the corresponding values, add those values, and write them to the amount of shifting on y function. Okay, that's the explanation of this convolution formulation. So I multiplied now for y0, I multiply 1 and 1 over 2. Now n is 1, so I'm going to write y1 equals, what should I do? For y1, I have 0, I have 1 over 2 at 0 and 1 at 0, okay? So the corresponding n values, 1 times 1 over 2 plus 2 times 1 over 2, 2 times 1 over 2, which will be equal to 3 over 2, 1.5, right? Half here, 2 half here, then I will have 3 half as my output at n equals 1. How about y of 2? Then I will multiply this one, okay? h2 minus k, 1 over 2 times 2, okay? You see 1 and 1. 1 over 2 times 2, like 2 times 1 over 2. This is the x values. These are x values. And these are h values, okay? X and h. And then plus 1 over 2 and 3. That means 3 times 1 over 2, which is 5 times 1 over 2, which is 5 over 2. If I write y of 3, what should I do? I should take this and move once more. It will be 3 and 4, 1 over 2, 1 over 2. And do I have anything here? 3. This is 0. And this is 1 over 2. 0 times 1 over 2 is 0. So there is no more overlap between my h and x, and I will stop my convolution properties at this point. Okay? How about y of minus 1 arkadaşlar? How do I find it? If I want to find out y of minus 1, then I should move this 1 to the left, and finally I should have minus 1 and minus 2 at this point. And there is no overlap again between this and this h of minus 1 minus k. Okay? So that's why it's also 0. Let us look at what we have found before. At 0, it was 1 over 2. At 0, it is 1 over 2. At 1, it is 3 over 2. At 1, it is 3 over 2. At 2, it is 5 over 2. At 2, it is 5 over 2. At 3, it is 3 over 2. That means we are doing something wrong. I hope you determined the problem, because this is not 3, but 2 and 3. You see, I'm moving 1 to the right. So this is 1, and 2, this is 2 and 3. So there is still a multiplication between this and this when I shift 3 minus k, when I obtain 3 minus k. So it is not 0 anymore, but it is like 3 times 1 over 2, which is 3 over 2. Okay? So same with this one. So these two things are giving me the same results. One of them is using a property called sifting property, in which I should write x of n as Dirac n's and y of n as linear combination of h of n's. This is the first way of doing convolution sum. The second way of performing convolution sum is using this summation formulation. Okay? So how will I start everything? I will start everything by plotting x of n, changing it into x of k. Just changing, instead of n, I will write k. And then similarly, h of n will be converted into h of k. Then from here, I will take the reflection to h of minus k. And then from h of minus k, I will put n minus k. So this will be my shifting amount, and it will be the value of my index at my output. Okay, so this is the basics of discrete time convolution. That means convolution sum. And now I will perform several examples, but I'm going to use the second formulation, second approach to apply the convolution sum formulation with some tricky parts in them. Okay, see you in the next video.